Hi everyone, welcome to Vedantu NEET English. I'm Diksha, your chemistry master teacher. And in this video, we are going to talk about most important naming reactions and distinguished tests. So let us start this and we are going to cover this within 30 minutes. So let us start this without wasting any time. First reaction is fatigue, Woods fatigue and Woods reaction. So you can say that, just remember that Woods is something that is alkyl and fatigue is corresponding to aryl. Okay, that is corresponding to aryl. Now in Woods reaction, you will have two alkyl halides, you will have one sodium, and in the end you will have the formation of RR. In Woods fatigue reaction, you will have one alkyl halide, one aryl halide, and in the end you will have the formation of aryl and alkyl attached together. But in fatigue reaction, you will have two aryl halides, where these two aryl halides will attach and you will have the formation of diphenyl or biphenyl kind of product. Right? Next is we have Wolff-Kishner reduction. In Wolff-Kishner reduction, what we have is we have a double bond O and we are going to reduce it into two hydrogens. And this is done in two things, right? One is basic condition, which is Wolff-Kishner reduction, where you use hydrogen in presence of KOH and heat, that is under basic conditions, right? But when you use this in acidic conditions, let's say same thing, that is Clemenzin reduction, but here what you have, instead of hydrazine and basic conditions, you have zinc amalgam and concentrated HCl, and here you will easily have the formation of, from ketone or aldehyde, you will have the formation of alkene. That means same reaction you are going to do, but this will be in presence of zinc amalgam and acidic condition. That will be your Clemenzin reduction. Okay. Next is, let us talk about some other reactions here. First is azodite test, or you can say that is coupling reaction. In this, what we will do, you will have the formation, you will have a azodite here, right? So azodite will be formed. Let's say you have disonium chloride. That disonium chloride, when it is reacted with phenol or aniline, what will happen? With phenol, what you will have? With phenol, you will have this kind of dye. Okay. So with phenol, you will have this kind of dye, where this is N2, and from the para position here, hydrogen will be taken out, right? So with phenol, you will have, this is OH, and with phenol, you will have orange color of dye. But when we talk about, ma'am, with aniline, what we will have? With aniline, you will have the formation of yellow color of dye. Okay, with aniline, you will have the formation of yellow color of dye here, right? And there is one more very, very important thing that I'll just write here, that if you have beta naphthol, or you can just write it over here only, that if you have, let's say, beta naphthol, I think I deleted the wrong slide here, right? If let's say you have beta naphthol, then in that case, if you have beta naphthol as a reactant, beta naphthol, then you will have red color of, scarlet red color of dye. Okay, the color of dyes are also very important. Now, next is diazotization. When you have aniline, to this you add NaNO2 or HCl, or directly you can say you add HNO2. Between 0 to 5 degrees Celsius, you have the formation of benzene N2Cl, that is disonium chloride. But the interesting part about this is, let's say you have RNH2. Okay, let's say you have RNH2, then you have the formation of RN2Cl, but condition is this R is alkyl. In that case, between 0 to 5 degrees Celsius also it is not stable, and it will directly give you ROH, that is alcohol. But in this case, because this is stable at 0 to 5 degrees Celsius, so you will have to warm it, and only then this N2Cl will be converted to OH, that is phenol. So this is also a preparation step of phenol. Next is Itard's reaction, where you have toluene. You can remember this T for toluene, Itard toluene, right? Then you add chromyl chloride in presence of CS2, and hence you will have the formation of benzaldehyde here. Next we have is fatigue reaction, we have done. Next we have Finkelstein. Let us start with the halogen exchange reactions. Finkelstein and Schwartz reaction. In Finkelstein reaction, you have RCl, which is under the presence of Na and dry acetone, is converted to Ri directly. But condition is, Either you can have RCl or you can have RBr. RI or RF is not possible. Similarly, in Schwartz reaction, you will have RCl or you will have RBr, and in presence of any inorganic fluoride, okay, like we have taken here silver fluoride, this will be converted to RF, right? Next we have is Hunsdiecker reaction, where you can have directly use carboxylic acid or you can use silver salt of carboxylic acid. On adding Br2 and heating it, you will have the formation of RBr, CO2 will be liberated and AgBr will be precipitated out. Right. Next we have is Gabriel phthalimide reaction, which is used for only preparation of primary alkyl amines. Right. So in this case, what we will do, we will have phthalimide here. Firstly, adding KOH, this will be replaced by K. Then adding RX, this will be replaced by R. Then when you add water into it, so what will happen? NaOH into it. So this will be ONA. This will be ONA. Here you will have hydrogen. Here you will have hydrogen. And in the end, you will have the formation of primary amine, right? In the end, you will have the formation of primary amine here. Next, ma'am, we have cumene process, which is very frequently asked. So in this cumene process, what you will have? Isopropyl aromatic ring, basically you have, this is the isopropyl group and this is benzene, right? So isopropyl benzene you have, which is also called cumene. So what will happen when you add O2 here? Two OO are attached here, right? In between, they will form a peroxide linkage, right? That is cumene hyperperoxide, and the questions are also asked for this intermediates as well. Then you add water in the acidic conditions here. This will be converted to phenol and acetone. So both the byproducts are important. Phenol and acetone is also very important. That is asked. Next we have is Dow's process. So in Dow's process, what you will do? You will have chlorobenzene, you add NeOH, you heat it, and the temperature is also something 673 Kelvin, I think more than that. So temperature and pressure is very high. So in this case, see, this bond is very difficult to break because of the double bond character here. That is the reason we are using very high pressure and temperature. We will break this bond. We will have the formation of ONA. And after adding acidic conditioned water, you will have the preparation of phenol here. Right here, benzene is formed as the intermediate. You can write it down. Benzene is formed as the intermediate here. That is benzene. And next important thing about this is, when NO2 group is attached at ortho and para conditions, the rate of reaction will increase. But at meta position, there is no effect of any electron withdrawing group, right? Next we have is Lucas test, that is for the detection of 1 degree, 2 degree, 3 degree alcohols. So for this, what you have to do, you have to see the turbidity here. So remember that the step is 3 degree, then 2 degree, then 1 degree. 3 degree will have the maximum turbidity, right? That will instantly form turbidity. 2 degree will form it after 5 minutes, right? But 1 degree will form after prolonged heating, and that too after 30-40 minutes, right? So this is what is written here. White turbidity, right? This primary is for gives turbidity after 30 minutes, after 5 minutes, and this gives immediately, right? So that is the detection of 1 degree, 2 degree, 3 degree alcohols. Next is Ball-Schiemann reaction. So now disonium chloride is a very important compound, right? So from disonium chloride only, I'll just directly write disonium chloride here, right? So you can also, because this HNO2 means this is converted to disonium chloride, right? So when you have disonium chloride, directly what you will add HBF4 here. Then this will be converted to this B negative F4 will be attached here as an ionic compound. After that, heating it, you will get the formation of fluorobenzene. But you know, this is called Ball-Schiemann reaction. But if you add HBF4, then you add NaNO2, then you add copper, then here you will have the formation of nitrobenzene. But this is not Ball-Schiemann reaction, that is called Ball-Schiemann reaction, right? Next is Hinsberg test, like we did for 1 degree, 2 degree, 3 degree alcohol. This is for 1 degree, 2 degree, 3 degree amines, right? So in this case, what we have, this is the Hinsberg reagent, that is benzene sulfonyl chloride. So in this case, what will happen? Directly what we will do, This is your, this is basically primary. So what will happen? This H and this Cl will be eliminated, and these two things will attach, and you will have benzene S double bond O. This is N will get attached to this S here, right? And hence you will have hydrogen and R here. Now primary will give you the reaction, but here because of this hydrogen, it will be soluble in aqueous NaOH, right? But when you have 2°, again what will happen? This Cl and this hydrogen will be eliminated. You will have this S is linked to this nitrogen here, and hence this will be the final product that is formed here. But here to this nitrogen, you don't have any hydrogen that is attached. That is why it is insoluble in the aqueous NaOH. But 3°, because there is no nitrogen, there is no hydrogen attached to nitrogen, so it will have no reaction here. Hence, it will be no reaction. So, different reaction only it is going to give you, right? Okay. Next we have is aldol condensation, which is a very important naming reaction. So here what we have, this is H, let's say this is C double bond O, this is, let's say, CH3, right? So I'm going to write it CH3 here, and this is H. So one you will use carbonyl carbon, and other you will use alpha hydrogen here, that is CHO. Now what you will do, you will connect carbonyl carbon with the alpha hydrogen, and in the end you will have the formation of CH3C, and this will be converted to OH. This is OH, this is H, this is CH2, this is CHO, right? So this will be formed in the end. But after this, what we are going to do, you are going to take out from alpha and beta position, take out the water here, that is condensation. So you will have the formation of CH3, CH double bond, CH, CHO, right? So similarly, this is self-aldol. When you have just one molecule, that molecule is only giving carbonyl, that molecule is only giving alpha hydrogen. But if you, let's say you have two compounds here, in that case, cross-aldol will occur and you will have multiple products, but the way of doing the reaction is going to be the same, right? Next we have is Cannizzaro reaction. In Cannizzaro reaction, this is basically a disproportionation reaction. Let's say you have C double bond OH. In this case, what you will have, one will be oxidized to the same number of carboxylic acid, one will be reduced to the same number of alcohol, right? So this will be formed in the end. But ma'am, if we have different, let's say ma'am, we have cross Cannizzaro reaction. See, in Cannizzaro reaction, first thing is you should not have no alpha hydrogen should be present. In case of aldol, there should be alpha hydrogen, right? So in cross Cannizzaro reaction, less hindered will form carboxylic salt. Less hindered will form the carboxylic salt. This you should remember. For example, let's say I have these two things. This is CHO and this is HCHO, right? So here the less hindered is this one. So it will form, less hindered is this one. So it will form carboxylic salt, and more hindered is this one. That's why it will form the alcohol, that is CH2OH. That is how you're going to do this reaction. Okay, so cross Cannizzaro automatically becomes very important. Next we have is Hoffman. Now Hoffman is a very important reaction, especially in case of iodoform. This is asked where you have the formation of CHI3, which is a yellow color, right? So now here, what are the reactions? So basically what will happen, this is the whole reaction that you can see on your screen, right? But this is given by which reagent? Okay, firstly reagent you can use either NaOI or you can use NaOHI2. But as you can see here, you have one alcohol, this is one ketone is also giving that reaction, right? So basically what kind of ketone, aldehyde or alcohol can give this reaction? So directly remember this, either you should have CH3, C double bond O, this kind of aldehyde or ketone, right? Either you should have CH3, COHH, this kind of alcohol, only then this reaction, this test will be given. Okay, this is a very important point. Next is carbylamine test, that is given by primary amines, right? Primary amines for the detection of primary aromatic or aliphatic amines. Here you have RNH2, which is directly converted to RNC, which is isocyanide, which is having a very foul smell, right? So in the presence of same reagents that we will use in Reamer-Timmer reaction, that is CHCl3 and KOH, right? Next is Reamer-Timmer reaction. As you can see, reagents are same CHCl3, KOH. So you should also know that electrophile in both the cases, is CCl2, that is dichlorocarbene, right? So here what we will use, we will have phenol here that will be converted to salicylic aldehyde if you have CHCl3. But as you can see, that can also be converted to salicylic acid if you have CCl4, right? For salicylic acid, we also have Coles reaction that I'll show you now, right? Okay. Now, Coles reaction, right? So here what you have phenol, but here in this case to have salicylic acid, you have the reagents that is CO2 and NaOH. The difference is in the reagents, right? And the name of the reaction, okay? That is Coles reaction. Next is Hofmann-bromamide degradation reaction. So in this case, you have amide, that is RCONH2. You add Br2KOH. This CO will be vanished off and you will have the formation of RNH2, right? That will be formed here directly, right? That is why it is called degradation reaction. Next is Birch reduction. So students, what exactly we will do here? Birch reduction is from alkyne to, from triple bond to double bond you have to convert. Basically, one pi bond it will break, right? So here you have liquid ammonia, lithium and sodium, and here you will have the formation of transalkene. But let's say, ma'am, I want to get, ma'am, cisalkene. Then what you can do? You can use Lindlar's catalyst, that is PDH2. In presence of any poison like BaSO4, you will have the formation of cisalkene, right? But this is not Birch reduction. This is called Birch reduction. Birch reduction is this one. This is not Birch reduction, okay? Next is Birch reduction in aromatic compounds. What will happen in aromatic compounds? So simply these are the aromatic compounds. Let's say directly, ma'am, we are adding same reagent, liquid ammonia, sodium, lithium, same thing, right? So one pi bond will break and two double bonds will be opposite to each other. Any position they can have, here and here, here and here, any position they can have, right? But when you have any electron withdrawing group, then it will take that position which is one space. That means one position you will leave and after that you will have the double bond, okay? So one position you will leave, after that you will have the double bond and the other double bond will be opposite to it. But when you have someone who is donating you the electrons, you are very happy that someone is donating me the electrons. So that is the reason you will have the double bond next to the electron withdrawing group, because you are very happy when someone gives you something, right? So that is why double bond is opposite to that. Next we have some other naming reactions, right? Friedel-Crafts alkylation. So in this case, you will have benzene, you will have RX here. The formation will be R positive electrophile that will directly attack here in the presence of anhydrous ClCl3, which is a Lewis acid, okay? So in Friedel-Crafts acylation, you will have the formation of R C double bond O positive. That is again going to attack on this benzene and hence you will have the formation of acyl benzene here, right? Getterman aldehyde synthesis. So that is Getterman-Koch reaction. Wait a minute. Getterman aldehyde synthesis. See, there are two kind of reactions. One is Getterman aldehyde synthesis, Getterman-Koch reaction. In both the cases, you will see here also you have C6H6 that is converted to benzaldehyde here also. So this reaction is in your syllabus. This reaction is not in your syllabus. So you can also skip this reaction. But still, if you want to see this, you add HCN, HCl, ZnCl2 and then directly you will have the formation of benzaldehyde here. You can see that that is a one step reaction. You can easily see that, right? So this is basically you have the attachment of C triple bond N here, then that is converted to aldehyde, okay? So you can go through that, right? But directly also you should know this is called Getterman-Koch reaction, which is a very, very important reaction. When you have benzene, that is directly converted to benzaldehyde, same thing, but here you have the reagents that is CO, HCl and anhydrous AlCl3, right? That is quite similar to Friedel-Crafts acylation, right? So next is Hall-Bohr-Zelinsky reaction where you have alpha, basically what will happen, let's say you have CH3COOH. So here alpha hydrogen will be replaced by the halogen. That means you will have the formation of CH2COOH, and this will be replaced by the halogen that you are adding here. Let's say I am adding bromine here, that will be replaced by bromine, right? Next is Hoffman-Mustard reaction. So here also this is not a very frequently asked reaction, but it is an important reaction. They can ask you surprisingly this question. Primary aliphatic amine, you add CS2, then you add HgCl2, you will have the formation of black color PPT, that is HTS. So this is a kind of, this is the distinguished test where you distinguish primary aliphatic amine, okay, primary aliphatic amine, which will give you black precipitate. Just remember this much, okay. Next is Hunsdiecker reaction that we have already done, right? Coles electrolysis reaction. So Coles electrolysis, and one more reaction is soda lime decarboxylation reaction. Let me see if it is there or not. I think it is not there. So I'll just write those two reactions over here, right? So two things you should remember is, in soda lime decarboxylation reaction also you have RCOONA, right? This is Coles reaction. So both are similar. This is soda lime, this is soda lime, right? This is Coles, okay? So exactly, this is not Coles reaction. This is basically Coles electrolysis. If I show you here, this is Coles electrolytic, right? So in this case, both the cases, what you have is the formation of, in both the cases, you have the formation of R, that is the hydrocarbon, right? But in this case, it follows a free radical mechanism. So that is why it will have the formation of RR. And wait a minute, that is opposite. Wait a minute. This was free radical mechanism, soda lime decarboxylation. This is a free radical mechanism, right? So that is why you have the formation of RR here. And this Coles electrolysis is at anode, at cathode. That is why here you will have the formation of RH, right? One thing to remember here, that here you will use cold electricity, you will pass electricity through it, right? But in this case, you use caustic soda, that is NaOH, and you use quicklime, that is CaO. That is how you got the answer, right? Okay. So directly I have shown you that what exactly you're going to do in Coles electrolysis in detail, right? Then there is Mendius reduction. In Mendius reduction, you have what you have? Aryl cyanide. Cyanide means either you will have RC triple bond N, or you will have ER, that means benzene ring, then you have CN. Now what will happen when you add sodium in presence of ethanol? What will happen here? Pi bonds will break, okay? These pi bonds will break here, and hence you will have the formation of RCH2NH2. That is what you will have when you add ethanol and Na, right? Next is Rosenmund reduction. So in Rosenmund reduction, it is you will have acid chloride. That means basically, let's say you have benzene or you have R, C double bond OCl. Okay, so I'll just write it R, C double bond OCl. And this is H is directly converted to aldehyde. That means you will have the formation of R, C double bond OH here, right? So here what you are using, again, Lindlar's catalyst, that is H2PDBSO4, right? Next is Sabatier-Sanderson reaction. This is when you have triple bond, but you directly convert it into alkane in presence of nickel, nickel as the catalyst. If you have alkene, then you will use 200 degrees Celsius. For alkyne, you will use 300 degrees Celsius, right? Next we have is Sandmeier's and Getterman reaction. So these two are disonium chloride reactions. So what you have is disonium chloride here. When you add, let's say, any salt here, right, then what will happen? This will be converted to, this is when you add salt, that is Sandmeier. When you have powder, that is Getterman reaction. So when you add salt of, let's say, copper of chloride, it will be converted to chlorobenzene, bromobenzene, or cyanobenzene also is possible in Sandmeier. But in Getterman, cyanobenzene is not possible, right? Because in Getterman, you can use copper powder and you can use HX, where HX can be either HCl or HBr. HCN is not possible here. That is an important point to mark, right? Then there is next one is Shortman-Baumann reaction, Now this reaction, you may have seen that, okay ma'am, this is the first time I'm studying this reaction, but in reality, you know that phenol, aniline and alcohol, whatever you have, the hydrogen will be replaced by C6H5CO, that is called Schotten-Baumann reaction. Let's say you had phenol, that is OH. This hydrogen is replaced by C double bond O CH3, that is Schotten-Baumann reaction. Let's say you have NH2, then this hydrogen is replaced by C double bond O CH3, that is called Schotten-Baumann reaction. Okay. Next is Stephan reaction, that is you have alkyl cyanide. So again you have alkyl cyanide. See, in Mendius also you had alkyl cyanide, right? So here also you have alkyl cyanide, but in this case you add SnCl to HCl and water. This is converted to aldehyde, right? So you have RCN, that is converted to RCHO, right? That is the difference between Mendius and Stephan reaction. So then there is Williamson synthesis reaction where you have RX, right? And you add RONA, that is alkoxide, right? That is added, phenoxide or alkoxide is added. And you have the formation of ether, that is ROR is formed here. But here the important part is this alkyl halide should be primary in nature. Only then this reaction is possible here, right? Last is you have Woods fatigue reaction. This we have done in the starting of this, right? Okay, students, I hope so that is clear to you. So it's just 26 minutes and we are able to complete most of the important reactions. One thing I forgot to tell you, that is 2-3 important tests here, because we are still left with some time here. So I'll just write down the test here. That is 2-3 important things. One is tolerance test, okay? One is tolerance test. Just remember that here you use silver nitrate. I'll just directly write, you use silver nitrate solution where you have the formation of Ag. Nobody is going to ask you the reaction. What they are going to ask you, I'll write it here, right? So you keep memorizing the reaction, but what they will ask you, this is given by which thing? This is given by aromatic, aliphatic, aldehydes. Then ma'am, this is also given by hemiacetal. This most of the students don't know. This is also given by alpha hydroxy ketone. On alpha position you have OH. This is also given by formic acid. Okay, these are the important things to remember. Then remember that whenever we talk about Felling test, Felling test is given by which of the following, right? Then remember that Felling test is given by aliphatic aldehydes. Right? Benedict test is also given by the same. But remember that in Felling test you use copper sulfate, definitely you use, right? That is Felling A. But you use sodium potassium tartrate. Here you use tartrate, right? Here you use citrate, right? These are the important points, and this is also called Rochelle salt. So these are some of the important points that you should remember, right? And guys, that's it. One more important thing to remember is that there is two kind of reaction. One is Reed's reaction. Other is Darson reaction, right? Now these are under the list of not very important reaction, but still, no, you never know what if they ask you this, right? So in Reed's reaction, in Darson reaction, you have ROH here, right? And in Reed's reaction, you have RH, right? So in this case, what you will have, in both the cases, you will have the formation of RCl, you will have HCl, you will have HCl, you will have SO2, you will have SO2, right? In Reed's reaction, in Darson reaction, you use SOCl2, right? Here you use SO2Cl2, okay? Just remember this thing, right? And you are done. This is called thionyl. This is called sulfuryl chloride. That's it. This is what you have to remember in the end. That's it. And I think we have completed all the reactions of organic chemistry. In 29 minutes, right? And now students, here we have for all of you, right? I know your exam is just 1 day away. So free NEET study material with NEETpedia we are providing you. Here you have the top most important NEET previous year questions. NEET question paper for 2022 to 2024 is provided to you here, right? You can just see this link here and you can solve, at least if you don't want to solve the 2022-2024 paper, at least solve NEET previous year questions. And I would really advise you watch my OMR sheet filling technique or strategy. From there, you can pick out any section, biochemistry, physics, whatever you want, right? From there, pick out one section and solve that with the help of OMR sheet filling to understand that are you able to do that within the desired time or not. So that's it for today, students. Till then, bye-bye, take care. And write down in the chat box hashtag your, you can write down NEET 2025 ready. Okay, write down hashtag NEET 2025 ready to show me your confidence that you have felt after this session. Till then, bye-bye, take care, see you all in the next class. Bye-bye.